Hello, my name is Beth Dixon, and this is part 2 of a video series based on Vicki Borlaug's PowerPoint presentation on the normal distribution. This PowerPoint is based on a standard z-table that gives the area to the left, and students need to have access to that type of standard normal table before viewing this video. We're on to topic number 2, the empirical rule for normally distributed data. Remember our normal curve, our bell-shaped curve, with the mean in the center. Notice we'll mark that as mu, mu being the symbol for the population mean. One standard deviation jump indicated by the symbol sigma, which is the symbol for our population standard deviation, then gives us mu plus 1 sigma, or the mean plus 1 standard deviation. 2 jumps and 3 jumps then gives us the mean plus 2 standard deviations and the mean plus 3 standard deviations, or mu plus 2 sigma and the mu plus 3 sigma. We can also move to the left by subtracting the standard deviation or subtracting sigma. And our 3 jumps in that direction leave us the mean minus 1 standard deviation, the mean minus 2 standard deviations, the mean minus 3 standard deviations, or we can read those as mu minus 1 sigma, mu minus 2 sigma, and mu minus 3 sigma. Within the 1 standard deviation in either direction, we know 68% of the data lie within 1 standard deviation of the mean. So within those first marks, 68% of the data lie. Within 2 marks, 95% of the data lie within 2 standard deviations of the mean, or 95% of the data lie within the mu plus 2 standard deviations and the mu minus 2 standard deviations. Then looking at 3 standard deviations in either direction from the mean, 99.7% of the data lie within 3 standard deviations of the mean. So 99.7 standard deviations lie between the mean plus 3 standard deviations and the mean minus 3 standard deviations. This is essentially all of the data. Remember, the bell-shaped curves theoretically go on forever and to the right and to the left, and that leaves us the other 0.3% of our data. This is called the empirical rule for normally distributed data, and that is a very, very brief review of the empirical rule. I do have a more detailed review of that in another video. Again, remembering 68% of the data lie within 1 standard deviation, 95% lie within 2 standard deviations, and 99.7% lie within 3 standard deviations of the mean. Here is an activity for you to try using the empirical rule to answer the questions. We will go on to topic number 3, word problems with normally distributed data. The weight of orange juice in a bottle is normally distributed with a mean of 64.24 ounces and a standard deviation of 0.12 ounces. And we have 3 different types of problems that we will answer based on that setup. We will concentrate first on part A. If a bottle is randomly selected, find the probability that the juice weight is more than 64.2 ounces. So with our setup, we know first of all that the data is normally distributed. We need to make sure that our data is normally distributed before we proceed. Then we draw our normal curve, our bell-shaped curve, with the mean in the center. We will label this as our x's, or which in this case is the weight of the orange juice in a bottle. We have a mean of 64.27 and a standard deviation of 0.12. I know these are the population mean and standard deviation because the sentence does not say that they're from a sample. Since they are a population, we will use the Greek letters mu and sigma, and place those on our graph, 64.27 under the center line, and I generally write the standard deviation somewhere above the graph so that it is out of the problem and in my own handwriting where I'm working the problem. That is what I call taking ownership of the problem. Underneath that, I will start with a z-value. Whoops, I went too far. I will start with a z-value, and I want to mark the weight that I have, which is the 64.20 ounces. Notice that 64.20 will be to the left of 64.27 just because it falls there on a number line. And I will mark the z-value underneath it because there will be a corresponding z-value for every x value. Our problem then wants us to find that it is more than 64.2 ounces. So I will shade that area and realize that that's the answer that I'm looking for. That is our answer. I will need to find the z-value first so that I can look up that z-value in our table. So our z will equal x minus the mu divided by the sigma, or x minus the mean divided by the standard deviation. X is the number we're talking about, which is the 64.20, minus the mean of 64.27 divided by the standard deviation of 0.12. Use your calculator to find that value, remembering to follow your order of operations. That gives us a negative 0.58. Notice that it is negative because it is below 0. That gives us our z-value. We will then look up that z-value in our table. When we look that up in the table, we get 0.2810, which would be the area to the left. Because that is the area to the left, that gives us 0.2810 to the left, but we're not interested in that area to the left. We want greater than or to the right, and with the area to the right, we want to do 1 minus 0.2810. That gives us 0.7190. And that is our answer for Part A. In Part B, we have, if a bottle is randomly selected, find the probability that the juice weight is between 64.10 and 64.40 ounces. Again, our setup starts out the same. Our bell-shaped, normally distributed data with 64.27 as our center and our standard deviation of 0.12. We then want to mark 64.10 and 64.40 as our z-values, as our x-values, and their corresponding values underneath for our z-values. Since we're looking for between those values, we'll shade between them on our graph, and that is the answer we're looking for. That means we need two z-values. Let's compute for 64.10 first. That would be 64.10 minus 64.27 divided by 0.12. and gives us a z-score of negative 1.42. and the area to the left of that number is 0.0778. That is the area outlined in blue. Notice we do not want that as our final answer because that is not part of our shaded region. We'll find the other z value next. So that would be z equals x minus the mean over the standard deviation and gives us 64.40 minus 64.27 divided by 0.12. That gives us 1.08, and when we look that area up, we get 0.8599. That is the area shaded in red. It is also not the answer because that gives us too much area. The area we want is not the whole area red, but the area in red minus the area outlined in blue. So we want 0.8599 minus 0.0778. That gives us a final answer of 0.7821. Before we do the next question, we will review some algebra. Let's look at the question 10 equals x minus 5 over 3 and review how we would solve this problem. The first thing we would do is to place 10 over 1, and then we could cross multiply, multiplying the 10 by the 3 and the x minus 5 by the 1. That would give us x minus 5 equaling 30. Then we would add 5 to both sides and get x equals 35. In the next question, to find x, we will need to solve an equation like this one. This one says 15% of all the juice in the bottles are above what weight? So we have 15%. And we want to shade 15%. Remember, 15% is going to be less than half, and it will be above or greater than. So that will be shaded to the right 15%. But since that is the area to the right, remember that we always look up in our table the area to the left. So I will fill in the area to the left as well to do the problem. And the area to the left would be the complement, 1 minus 0.15 or 0.85. We are looking for, in this case, not a probability, but the weight. Since we're looking for the weight, we're given the probability, we still want to find the z-score first. But in this case, we will look in the center of the table for the value closest to 0.85. In this case, the closest value is 0.8508, which gives us a z-value of 1.04. Once we have the z-value of 1.04, we can then use our formula to calculate the x. Think about it. We have a z, we have the mean, and we have the standard deviation. We're missing the weight. So plug in the z, plug in the mean, plug in the standard deviation. Now we can solve by cross multiplying for x. That means we will multiply 1.04 times 0.12, and that will give us 0.1248. Multiplying 1 times x minus 64.27 gives us x minus 64.27. Then to solve for x, we will add 64.27 to both sides of the equation, and our final answer is x equals 64.3948. And that's approximately 64.39 ounces. Please follow your teacher's rounding rules when rounding your numbers. So your answer is approximately 64.39 ounces. Here is a student activity for you to try. Thank you for watching, and if you need additional help, be sure to stop by and see me in the Mathematics Learning Lab in MBSS 222. Thank you.